And is it possible to build a recommender system with unstructured data? Or do you need to pre-structure the data through, for example, classification?
That's a great question. I think it's at the very core of what we are doing.
Hi everyone, it is Lauren Hawker-Zaffer. Welcome back to Redefining AI, the Tech podcast. I'm an educator and I'm taking you on an educational exploration into the fascinating minds of those that embody and forefront all you need to know about artificial intelligence, machine learning, insight engines in the insight era. This episode is called Spotlighting Knowledge Graphs, and it's an ode to the knowledge model and the corresponding technologies that are intertwined into providing the knowledge management world with tools that put data in context whilst providing a framework for data integration, unification, analytics, and sharing. My guest and thought leader today is Andreas Blumauer. Andreas is the CEO and co-founder of the Semantic Web Company, the provider and developer of the PoolParty Semantic Platform. With headquarters in Vienna, but operating globally, the SWC has worked with over 200 commercial, governmental and non-profit organizations to deliver AI and semantic search solutions, knowledge platforms, content hubs, and related data modeling and integration services. The SWC, it was listed on KMWorld's prestigious list of 100 companies that matter in knowledge management from 2016 to 2021. And it has been named multiple times in the Gartner Magic Quadrant for Metadata Management Solutions and as a sample vendor in their hype cycle for natural language technologies. In his role as CEO, Andreas is responsible for both the strategic growth of the company and its organizational evolution towards highly focused customer orientation. Now, many of you may not know, but I'm a corpus linguist, so the topic forefronted today is of great interest to me, and it should pose as an exciting discussion for all of us. So Andreas, it's a pleasure to have you here. Welcome all the way from Vienna, the wonderful city of Mozart. Are you a fan?
Hello, Lauren. Thanks for the introduction. How are you today?
I'm wonderful. Yourself?
Yeah, all good. All good here in Vienna.
Are you a fan of Mozart then?
Yes. I mean, I should say rather yes, but to be honest, it's not exactly the music I typically listen.
Yeah, of course. Vienna's a wonderful city, so I'm sure that you're honoured to be based there. There's a lot of wonderful things that anyone listening, if they've not been to Vienna, can certainly explore and see. So Andreas, we've got you here, and as I mentioned, we're spotlighting knowledge graphs. Maybe the question would be, where do we start? I would personally imagine that a good place to begin may be with the name Tim Berners-Lee. No? Who is he and how does he fit into the narrative that we're sharing today with our listeners?
Yeah, excellent starting point, because obviously it was him also bringing this whole idea to me, to us, into a big community, and in the meantime to a really global community. Some of the newer colleagues in the knowledge graph community probably haven't thought about that, really, that the roots, of course, are laid by Tim Berners-Lee and W3C and the Semantic Web Standards. They're still kind of the foundation of all what we are doing in the knowledge graph community. In the meantime, there have been a couple of new terms introduced. Somewhere in between, it was called rather linked open data, linked data. Now we have the knowledge graph in place. Next iterations are already underway. You could also easily say a semantic data fabric is kind of a next generation knowledge graph implementation. But in all cases, there's W3C standards like RDF, Sparkle, etc. At the very core of what we are doing. But what's also important, it's definitely not just the standards and the technologies. What we have seen it's more about change management in organizations, the new way to deal with data in general, with content. It's a highly collaborative environment, which is developed in any knowledge graph project. That means new governance models have to be established, and that's probably the biggest bottleneck in most cases. It's a new way to deal with data and look at data. It's no longer this highly centralized approach. It's like the semantic web originally was designed for the World Wide Web. So obviously no centralization is possible. At the same time, interoperability of between different sources is more important than ever before. And when looking at, for instance, supply chains in our today's world, it's even more important now to come up with more and more standards around data. So the semantic web was a big vision of Tim Berners-Lee for the World Wide Web, first of all, and now has been implemented in many organizations, whereas on the web, it probably hasn't reached the level as probably Tim Berners-Lee initially has thought. There are a couple of platforms which kind of came in between these plans. To name one, Facebook definitely is a bit a competitor of the original semantic web idea. But let's see, there's a next wave coming in.
Okay. You mentioned one word a few times there. So you mentioned semantic web standards, you mentioned W3C standards, you mentioned standards there just in the latter comment that you gave. What's the circulation around standards and obviously how we've introduced sort of the semantic web?
So the initial phase was very much of academic discussions. So it took a while until those standards got implemented in enterprise-ready platforms. In the early days, I remember it was like 2004, 5, 6 or so when we started out to create first technologies. It was very obviously immature. Graph databases didn't work on enterprise level. In the meantime, the standards are really embraced and circulate in many different platforms and ecosystems. Just think about Neptune on Amazon, for instance. They have implemented also the W3C standards. At the same time, of course, we should be clear, graph technologies could be not just what W3C has supported, but also LPG graphs, so that's the labeled property graph standards, which now come together more and more. So there have been also always these discussions between the two graph communities. So which one is the better? In reality, none is better than the other. It really depends on what you want to do with the data. At the end of the day, if it's about data integration, interoperability, then definitely the semantic web standards work better. If you want to do certain types of analytics around your graph structures, then probably LPG works a little bit better. Anyway, now things come together and there are already new standards out there which bring the two communities together. And so it has, developed in the past 20 years in a quite nice direction, I would say, because most of all, the majority of the data people now have understood that graph is not an academic exercise anymore, and just a couple of nerds believe in that, but it really complements the modern data stack with some tools which are really important to get one step further towards explainable AI, for instance, or better data analytics, or let's say more efficient data integration methods which knowledge graphs can support.
And I think that's probably a good segue, because it is all about data. And obviously in relation to understanding the semantic web and how this concept leads on to understanding knowledge graphs in detail, I think that probably we need to look at the data that is forefronted or used or that does play a role. I've seen myself that two types of data play an important role, and maybe there's more, and that's obviously why you're here to give us an insight into this. That linked open data and semantic metadata are two important concepts in data forefronts. when we're spotlighting knowledge graphs and data knowledge management. Is that true? How do they, or what role do they play?
I mean, just to explain that maybe a little bit more in detail, it's definitely not about replacing any existing data infrastructure. It's about complementing, enriching the existing data points with consolidated and consistent metadata on top. Plus, it brings in knowledge models. So I think that's very important to see. There's at the moment two types of, let's say, again, ideas how to use knowledge graphs around two communities. So the one is really very focused on, okay, let's use knowledge graphs for data integration. Let's put the semantic layer on top of all the existing data sources, and then let's link that more efficiently. And if you want, you can, of course, then much easier also bring in third-party data sources, so you can integrate internal with external data. You can integrate unstructured data with structured data and so on. So that's the one. And then the other approach, and so to speak, community says, okay, let's use the data we have, and then let's put some additional knowledge on top of that. Plus, of course, the semantic metadata, the consistent metadata, the semantic layer, plus knowledge models. So we put something next to the data we have, which is a kind of a domain model. And the domain model could then be used for various reasons. So one is definitely better usability, let's say better user experience in an insight engine. That's one. Or the other one is you use this kind of knowledge to do consistency checks, to validate the existing data. Or you just, and that's a bit another strain, so to speak. It's like, okay, let's use the knowledge to do reasoning, to put some additional facts next to the fact base we have already in our databases. So there's various, let's say, perspectives on why knowledge graphs could be useful. And that makes it at the same time also a bit complicated, this discussion, because there is no such a thing, which is, one concept for a knowledge graph. And it's like this, the elephant and the blind man metaphor, where people start to see, okay, what is in front of me? And the one touching, the elephant, maybe at the foot says, oh, it's a tree. And then the other one touching the elephant somewhere else on the body says, oh, it's a snake, etc., etc. So this is very complicated, this discussion, I've learned. And the first thing, because of that, what I always ask when we start a conversation is, where you come from? So what's your background? And for instance, you said you're a corpus linguist. That's yet another great way to use knowledge graphs, because when you start using a lot of unstructured data and you want to probably put some machine learning around that, extract, let's say, most important sentences, etc., then obviously a knowledge graph can really help to accelerate the training of your machine learning models. That's another frequently seen use case now, when knowledge graphs become kind of an additional source to train your models. So machine learning highly benefits from semantic metadata and the background knowledge, which is important in a given domain.
And have you seen that there's been positive embodiment of the latter? I mean, you mentioned that sometimes the understanding the concept of a knowledge graph per se is a more difficult topic. When working in the domain of using it for machine learning, have you noticed that there's positive adoption and understanding of that in that domain?
Well, simply spoken, now the machine learning community is open to the idea of using knowledge models to do, for instance, data labeling and preparation of training data. I remember like 5 years ago or so, when you came to a meetup where the machine learning people heavily discussed what is the next best algorithm for a certain task, and you were approaching them, talking about semantic web and knowledge modeling, they really told you, no, sorry, no need for that kind of data. We don't need you. So it was really this, again, symbolic AI versus statistical AI, two tribes not talking to each other. But this situation has changed in the past 4 years. I would say it's like, okay, some of the bigger machine learning companies, they came obviously to the point where they've seen, okay, from an algorithmic point of view, it's no longer possible to really reach a next level of quality. So obviously it's about the data itself and also this ability to bring in a knowledge model into the mix. So you cannot train algorithms to do something which is not even in the training data written. It's not there. It's not, this knowledge isn't in the databases or in the data sources or in the content. It's just not there. It's somewhere else. It's typically in our heads. And if you want to encode that and bring that next to the machine learning models, you need to fuse those two worlds. And I guess that's really the next big step here. It's all around. This discussion is very vibrant. In the meantime, I mean, if you look at the research papers which have been published in the past 10 years, this fusion has been underway for a long time, but now it starts to get commercialized. It's always like 10 years research, and companies start to implement that and productize that. And so this is really the next big step, this composite AI topic where different AI methodologies get fused and so there's so many ways to combine graph with machine learning. That's really exciting.
Yeah, I was going to say, I mean, I think for AI architects, I imagine that they would benefit a lot more from composite AI than graph technologies and as a segmented offering. And I think that's obviously what you're trying to express here, that it really is a beneficial sort of fusion between the two, this composite AI. We can go back to composite AI in a little bit more detail, but I think that just as well to spotlight the whole graph technologies, there's two concepts or two terms that you always hear if you're reading about the technologies, if you're reading about the space, and that's ontology and taxonomy. And I've heard personally these used in very interchangeable different ways. And you ask one person what's taxonomy, what's an ontology, and they'll give you ambiguous explanations. So maybe from an expert like yourself, Andreas, you can give us a definition of what are these and why are they important?
Yeah, so if you, okay, I do two explanations. So the one is more away from all the standards, kind of an explanation that it can be understood if you're not familiar with the standards even. So if we look at let's say in your kitchen, you have tableware there, you have maybe some ingredients somewhere put in at a certain place in your kitchen. You have maybe some kind of recipes in mind you would like to cook and things like that. That's the ontology, right? So you know what can you cook because you have probably gluten intolerance. So this is the ontology. This is, you know, what types of things are needed to cook something. What kind of knowledge you have to cook something. That's expressed typically with the ontology. And the taxonomy then is kind of more on the instance level. So you really go down to the details, take a look at the names, what different things have and how they are classified. So it's really for classification. Taxonomy is a great way to quickly, in contrast to an ontology, create a knowledge model which helps to classify instances of things and takes care of naming conventions. And by that, it's a great source of truth to do automatic text mining in general. And the ontology piece is, let's say, more on the abstract level. It's definitely frequently used for schema management. I mean, schema.org, which is heavily used also on the World Wide Web by Google and others. It's a very simple ontology. And I think that's definitely also the level of expressivity what ontologies are now typically used for. So the good old heavyweight ontologies, which then also contained axioms and things like that, are not that much used in industry. But for schema and for the abstraction of what kind of things are out there and which classes of things are out there and how they relate to each other on an abstract level, it's a great way to use ontologies. And there are standards. So the SCOS standard is the W3C standard, which is heavily used to create taxonomies. It's not talking about the governance model or the way you create them. That's always a matter of discussion with any organization, because there are various ways to create taxonomies, but how to put them into a formal data representation format, that's definitely SCOS. So, and SCOS, and now the confusion is complete, I guess, SCOS itself is an ontology.
Okay.
Which
and
is, yeah.
And SCOS is the SKOS, SCOS. I mean, it's a standard, obviously, that a universal data representation standard, or?
Yeah, it stands for Simple Knowledge Organization System.
Okay.
And originally, it was actually designed to have this interoperability layer between different taxonomy and thesaurus standards. But you can use, obviously, SCOS very nicely also just to create taxonomies natively on SCOS and then, use them as a first starting point for a knowledge model, which then later drives the creation of knowledge graphs, where the majority of the steps are done automatically. Of course, you don't want to create a big knowledge graph by hand. But taxonomies are typically a kind of, there's the human in the loop. So you need people who take a look at the taxonomies and obviously also on the ontology part of your knowledge model, that this has really, really good quality. From a quantity perspective, it's probably 1-2% of a knowledge graph, but it drives the automation steps.
Okay. So obviously with the qualitative perspective of the human in the loop, and they're looking at the build-up of the taxonomy, if we look at maybe from a statistical representation from data, where does master data management fit into that? Because they're both fundamentally concerned, like knowledge graphs and MDM, with creating a unified overview of data that could help with the build of a taxonomy.
Yeah, there's a huge convergence now underway. So there's MDM, master data management, there's metadata management, there are data catalogs, there are all kind of data modeling exercises, which now eventually come together, and it's called the semantic layer, if you want. So the MDM systems, which are currently used, are a bit rigid. That means they do not really embrace graph, and that's the biggest disadvantage of the existing MDM systems. So that they just have started to understand graph is more flexible. It's nice. It nicely fits into agile methods, so you can extend on your models quickly, and you would not break up any existing applications necessarily, because it's really decoupled. So application logics is no longer containing any data models that much. It's really decoupled. So as it's nicely described, semantic web standards are also good for self-describing data models. So there's no need to have a manual anymore. So what does the database mean? So what does this column with the header code A, B, C, 1, 2, 3 mean? It's self-describing, and it's based on a formal logical model, really. So it's not just a proprietary format anymore, and that makes semantic web such a great way to create a huge ecosystem, across organizational boundaries, where data can now start to get linked and better understood by the other parties in a value chain, and so it's really a way moving forward that human beings can work together at scale, and that's what I really like about the semantic web and knowledge graphs in general. People collaborate more efficiently. We need that.
Mm-hmm. You mentioned at the start there, obviously, it's quite a good use case for those in HR. And I recently watched one of your videos. You'd hosted a seminar, so PoolParty had hosted a seminar, and they'd highlighted a successful business case that forefronts the use of knowledge graph technologies and knowledge models in knowledge expert finding.
Mm-hmm.
Would you say that this is representative of a successful business use case that maybe we can talk about, and you can show that this is representative of why and how this can be used in implementation in a business unit?
Definitely. I think what we currently see is that the new work and the digital workplace and all this infrastructure needed to make people work together more effectively in days of a lot of working from home, and it's HR is definitely one of the units, business units in any organization which is currently looking around for new technologies, and semantic knowledge graphs are used heavily in this industry and in this part of any organization. And it's also a great example of how standards can help organizations to, for instance, recruit people more efficiently. There's, for instance, the ESCO, the Thesaurus out there, the European Skills, Competencies and Occupations Thesaurus. It's it's open and free. You can reuse that, and of course you can repurpose that to your specific industry, and it helps to enrich, for instance, a CV, a biography of people with background knowledge, which typically probably people would have, like the recruiter would understand. Okay, in the curriculum vitae, somebody says I'm an expert for, let's say, prints as a standard, and then you can infer from that, then that person must be really a good fit for our new project management position. I mean, that's a trivial example, but it's the way it works. So it's probably not written explicitly in a application, a motivation letter, but as an expert for labor market and for skills and occupations, and also the universities and colleges people attended, you can infer if it's a good fit or not. And that's something you can partially automate with a knowledge model running in the background. And that's exactly what this HR recommender can do quite well, bringing people together with open positions, projects, or the customer comes up with a new specification and you have to fill the open positions in this project. So who are the best people in my company who could do that? So it's project configuration. Yeah, many such quite complicated steps towards a successful human resource development can be fulfilled and can be supported by such applications. And it's a mixture again of, let's say, typical machine learning based text mining plus knowledge models which contain the knowledge of a certain domain.
Yeah, it's fascinating. I mean, the assistive capabilities and what you can do with those is wonderful. And I know that you, Andreas, as well, that you've built a recommender system based on knowledge graphs. Does some of this background knowledge, that's required, does that enable you to build better recommendation systems or recommender systems? And is it possible to build a recommender system with unstructured data? Or do you need to pre-structure the data through, for example, classification?
That's a great question. I think it's at the very core of what we are doing. So it's obviously always about precision. So, I mean, recommender systems are only accepted by people if they come up with really good recommendations. If there's a set of bad recommendations coming up, then you probably switch it off. I mean, we all have had such recommenders
Of course, yeah.
our desktops in earlier days, which we switched off because we didn't like it. And so we really need recommenders which understand the user as a persona, as a person who has some tasks to fulfill in a given context. And by that, it really has to have the ability to triangulate the potential answers or the potential good contents and the knowledge pieces and knowledge bases available. I have to triangulate that with the intent and with the context of the user. So such models are great for personalization, and personalization is the foundation layer for a good recommender engine. And here you need a domain knowledge model. So this is typically not that precise if you would leave that out in your AI architecture. It's not written in the content, this kind of knowledge, what a good recommendation is about. So it's worth looking at that in more detail. If a recommender should be implemented at a digital workplace in an enterprise, to which degree you should start to complement your AI architecture with semantic knowledge models. This is really a key question we currently go through together with a couple of our clients.
Yeah. I mean, it is, and I think that probably one of the most difficult challenges is the inference. Like, how do you infer a user's intent and trying to understand that user as a persona to be able to really build this knowledge model in the recommender.
Right.
We've not got too much time left, Andreas, but we do have a couple of questions from our listeners. So they've submitted a couple of questions. How are you educating the market about knowledge graphs?
It's much easier than 10 years ago to talk about knowledge graphs, I have to say. So that like 10 years ago, it was very strange when you approached someone and talked about graph technology. So they looked at you and said, who are you and what is that? And in the meantime, people are very open-minded and they say, always tell me more, graph sounds interesting. So what is it? And I think it's worth reading a couple of books or watching some videos. I mean, there's a lot of stuff out there. In the meantime, also what's quite, let's say, for practitioners in the meantime, also there's a lot of stuff. It's not just, let's say, the very academic approaches anymore towards semantic web adoption, which is, I also appreciate, don't get me wrong, we need people who lay the foundation, but then there are others who have to explain also the business value, and that's two different narratives really. And I always say to people who would like to learn more, let's try it out. I show you examples. There are lots of demos and lots of little applications which already showcase the real benefit of what you can do with that. And then, of course, when it comes to the question, how can we start such a project? How can we implement that's a different story. So here we have to take really look at the resources, especially at the human resources. So which people could work on that and which background do they have? And I mean, that the minimum is really that people start to understand kind of the anatomy of a graph. So it's like when you start to learn medicine and want to become a doctor, you should know how the human body kind of works. And this is really the starting point. So what is a graph when you really look at the internals and what are the pieces and the components, and you will quickly see you have already a knowledge graph. Any organization has a knowledge graph, otherwise it wouldn't work. but the point is it's not digitized sometimes that much. So it's like in our heads, it's somewhere in emails, it's not structured, and most of all, it doesn't use any standards which makes data interoperable. We won't centralize our data management, and that's great. We're living in a more and more decentralized world. So by that, we need a way to bring data in front of others that they can easily ingest it, and therefore you need interoperability standards. That's what a graph essentially is, but we have that already. We have to transform them into digital assets. There are standards for that, there are tools, there are databases, it's all there in the meantime. And that's what we, of course, try to explain in little videos. We have the PoolParty Academy, I have the Knowledge Graph Cookbook together with my colleague, which contains a lot of knowledge. And then there are many other sources out there, like, for instance, the Squirrel Academy.
Yeah, I mean, I think that it's a never-ending, but also rewarding path that people, organizations have to follow to really enhance and empower individuals. Because education is all about empowerment and enhancement. And I loved your analogy looking at the anatomy of a graph. And I think you've probably convinced a lot of listeners with that analogy to maybe take an opportunity to explore. And as you've mentioned as well, you've got your own educational resources that are available on the PoolParty Academy. So they're certainly there for all of our listeners to explore too. Thank you very much, Andreas. It's been wonderful having you on the show today on Redefining AI. I've certainly learned a lot, and I'm sure that everyone else listening has. Would you like to say anything, share anything with us as we part this discussion?
Yeah, first of all, thanks, Laureen, for this nice talk, and thanks for giving me the opportunity to talk about knowledge graphs in this forum. Famous last words. I think it's the only thing I would like to share at the very end is if you are, as a listener, about to start to learn more about knowledge graphs, I really would recommend to take a look at example applications first. So it's a very, otherwise it remains for a too long time too abstract. So if you start with OWL and SCOS and RDF and whatever, it's very abstract. It doesn't work that easily then. It's better to take a look at existing applications, and then you will find out, oh, there is no knowledge graph. Where is the knowledge graph? And it's just not visible sometimes. The graph is not the visualization of the graph. And that's what people most frequently get wrong in the first round. It's not about visualization. It's about a model which is running in the background, driving the quality of your great and smart applications.
I'll have to try it out myself.
Okay, thank you very much.
So I want to thank everyone for listening today. If you want to learn more about AI, ML and search, then come and take one of our free courses at learn.squirrel.com.